Sheet Metal Training Step 3 Part 1 Data File Pressure File Relation. To begin, enter the job file and add a new zone. On the lower right of the screen, click the Add New Zone button and type in a zone name. Click the OK button and select the default pressure files. For today's lessons, I'll select 2-inch. Click the OK, and the screen will change over to the takeoff and load the appropriate files. We will begin by selecting a piece of duct. Standard length of 4'11" and dimensions 24 by 12. Listed directly below, we'll see the default construction standards for this item. 22 gauge is the default gauge. The joint connection is galvanized standing S and drive with a duct sealer sealant. The seam is a snap lock with no seam sealant. No angle reinforcement and no rod reinforcement is required. To the left, you'll see that the 1-inch by 18 gauge galvanized strap is the default hanger. All of this information is coming up as a default due to the fact that we loaded the 2-inch standard SMACNA low pressure galvanized file. SMACNA duct construction standards dictate what information needs to be brought up with the item. You can also customize these settings per your own company's duct construction standards. To modify these over, simply click one of the drop-down menus or the pop-up menus in order to modify any particular construction item. For instance, the gauge. Let's modify that from 22 to 22. As an example, we'll modify the gauge from 22 to 24 by clicking the drop-down menu and selecting the new gauge. The new gauge is changed to a yellow background, letting you know that it is not the default for these construction standards. However, you still can make this override. It is an allowable alternate. Same can be said for all of the other joint components. Clicking on the galvanized standing S and drive will give you the joint pop-up in the upper right. Select the new joint you wish to go to, for instance duct mate, and you'll see that the duct mate is then changed over as the new joint connection that is currently turned on. The program immediately looked over and saw that duct sealer was the joint sealant and knows that it is not an allowable alternate with the duct mate, bringing up the joint sealant chooser and asking you to choose a new joint sealant. I'm going to select butyl gasket. Butyl gasket is now turned on and yellow. So these are allowable alternates, but not defaults. Your allowable alternates are set up in the pressure file as well as your defaults for the different components that you want applied to each of the individual items. We can modify any of the construction standards for this item on the fly by using any of the allowable alternates we have set up within the pressure file. This item has been completely changed over from the duct construction standards using all of the allowable alternates. In order to view those allowable alternates, we'll have to leave the takeoff screen and go back and edit the pressure file so that we can look at all of the items that are available. Let's set this item back to defaults so that we could then use it as our example and view all of the items that are set up in the pressure file as a default and view how to change those defaults to a different set of duct construction standards and allow different items. We will now go back to the setup menu and view the duct construction standards for the currently loaded 2-inch standard SMACNA low pressure galvanized file. I'll accept this piece of duct so that we can view how the item was originally set up and see any of the changes that we've made. We leave takeoff by returning to the job file, selecting the main menu at the top of the screen, and then clicking the setup menu. You'll need to view the rectangular pressure files that are currently available and select the pressure file that you wish to edit, in this case the 2-inch standard SMACNA low pressure galvanized. Move to the bottom of the screen and click the edit button to have the pressure file brought up. The pressure file menu looks the same for all pressure classes and material types. The top of the screen in the title bar will always show you what pressure file you currently have edited, 2-inch standard SMACNA low pressure galvanized. The column on the left-hand side has the duct construction standard settings for the currently loaded pressure file, the material types you wish to use, the scrap percentages, as well as the seams and joints and reinforcements. The item that we were looking at was a 24 by 12 standard length piece of duct. Let's view the seams. On the left-hand side of the screen, you'll see that there is a duct seam column going by the big side of the duct. Just as the SMACNA duct construction standards are dictated by the largest dimension of the ductwork, so is the QuoteExpress setup. If we come down to the 24-inch line and look at and see what the seam code is, we will see that there is a number 2 in there. Look to the bottom of the page and you'll see that a seam type 2 is snap lock. The number that is in the column is the dictated default to the pressure file. The boxes that are checked at the bottom are the allowable alternates. If you remember, I modified the item when I brought it up and used a Pittsburgh seam on it. I was able to do this because it is a checked allowable alternate. You can check and allow any of the seams listed at the bottom. Just by checking or unchecking, you are then changing the allowable alternates for those items. To change the default seam, simply change the number that's in the column. For example, if we wanted that 24 by 12 piece of duct to now use a Pittsburgh seam, I would just modify the column over to show a number 1 in there. You can see that the columns are separated between duct and fittings. The fittings can have their own separate default seams from the standard length duct. Coil line duct might be manufactured with a snap lock seam, where all fittings are going to be manufactured with a Pittsburgh seam. It allows customization per shop standards. I'm just going ahead and change that back to a 2. Next we'll look at the joints and reinforcements page by going to the menu and selecting the joints and reinforcements. First we need to determine the length of the item that we're interested in. We were looking at a 24 by 12, 5-foot long standard length piece of duct. We'll refer to the 60-inch centerline length table. Again, it works off of biggest dimension, so we'll come to the 24-inch line and we'll see that the default gauge is 22 gauge. This is not a code column, this is a gauge column. By clicking in here, you'll see that we are shown that it's 22 gauge. Again, if I wanted to modify it over to a default of 24 gauge, all I would have to do is highlight the field and change it over. Next over we have the joint connectors. The default joint connector is a number 3. If I click into the column, you'll see that the joint codes are then shown to me at the bottom. A number 3 is galvanized standing S and drive. Same as the seams page, I can modify it just by changing any of the numbers in the column, and that will change over what the default joint is. Also, checking the boxes at the bottom will also change the allowable alternates. You'll see listed at the bottom that we have stainless steel TDF, we have stainless steel duct mate, we have stainless steel S and drive, and aluminum joint components as well. All of the joint components that are set up in the program currently are available to you in every single pressure file. However, since we are in a galvanized pressure file, it would not make sense to have an aluminum TDC checked as an allowable alternate. That would just allow yourself to make a mistake. Only allow the material type joint connectors that are relevant to the pressure file that you are currently working in. QuoteExpress will automatically look at the centerline length of each of the individual items to determine which joint construction table it should pull from. Standard length 5-foot duct would pull from the 60-inch table. If you had a 36-inch long transition, the program would automatically pull from the 36-inch table. If you had a 6-inch angled tap-in, the program would pull from the smallest table, which is the 24-inch. This allows you to adjust the gauges per the length of the item. Shorter the item, lighter the gauge. You can also remove the center reinforcements such as center tie rods or center angles. The program will automatically respect these changes and make the modifications within the takeoff screen. To better understand how the program puts the components together on the items, we should look deeper into how the joints and reinforcements are set up. Going back into that page, you'll see down at the bottom that the joints are listed in a grayed out field. By clicking on the name, all it does is check or uncheck the box. It doesn't actually allow you to modify the descriptions. To modify the descriptions, you'll actually have to leave the pressure file and view the data file. To do this, go to the menu button and click the exit button. On the left-hand side of the screen, you'll see that there is a data file button. Click the data file and it'll open up on screen. And we were looking at the joints page, so let's immediately go to the rectangular joints and sealants. Here, you'll see that you have your galvanized TDF, TDC, galvanized S and drive, all of the different joint components listed on the code line that they represent. Throughout all of the pressure files, they'll always refer to these codes. These are simply static locations for the pressure file components to be listed. If you move the location of these items, it'll actually move the locations and change the codes within the pressure files. Could make your setup inaccurate. To better understand the changes, you will see listed on this page all of the rectangular joint connectors that were viewed within that pressure file. Galvanized TDF TDC, galvanized standing S and drive, duct mate, welded, all of these joint connectors are available for all material types. You have one data file that handles all of your pressure files. You can see the descriptions going across horizontally are then asking what the bend allowance would be for this item, 4 inches taken away from a standard length in order to turn the TDF or TDC flange on the end of the duct. The cost for the cleat, which runs along the horizontal component, is 29 cents. On the vertical side, we have the same thing, which is a cleat, 29 cents. And then the corners, nuts, and bolts that are used for a complete connection, so that would be 8 corners and 4 nut and bolt combos, that would total $2.65, so the each assembly would be totaled in this location. Galvanized S and drive requires a 1-inch bend allowance, only turning the half-inch drive on each end of the duct. On the horizontal side, we have the flat slip, which is 30 cents a foot, and on the vertical side, we have the flat drive, which is 20 cents a foot. Listed a little further down the page, you'll see the galvanized duct mate 35, and all of the descriptions for it. The information listed on this page is published through all of the pressure files. So by changing a price on this page, you change the price in all of your pressure files. This saves you time. You don't have to edit all of the pressure files and modify the material prices or the standards due to the fact that everything points back to the same data file location. To better understand the data file, let's set up a new joint connector. We'll come to the first line that is available, which is line 16, and we'll change the description none over to a new description. For this example, we use galvanized test connector. For this example, we'll say that it's a slip-on flange, just the same as duct mate or ward frame, which is requiring no bend allowance. We'll then jump over to the horizontal description and modify the word none over to what we want the horizontal flange to be. For this case, we'll use an H flange. Same thing with the vertical side, we'll use a V flange for the vertical side. Putting in a cost per foot, as an example, 50 cents a foot, and the same here. Now the components. This would be all of the items that would be required to make up a connection that are not priced on a per foot basis. And we can put in a dollar amount for that. We'll use $5 for this example. After setting up all of these different columns, this component is ready to be used. To make it available, let's go to Menu, Exit, and we can now start using this file. We will now return to the takeoff and use that joint connector. Go into the main menu, the job file, and then editing the zone that we've already entered. You'll see the data file in the pressure file is reloaded. By selecting that rectangular straight duct again, we can now come up and click on the joint component. However, our new joint connector is not an available alternate here. Why is that? We never visited the pressure file and checked to make it an allowable alternate. So to do so, we need to hit Cancel, Job File, click the main menu in the upper left, Setup menu. We will now need to visit the 2-inch pressure file by clicking the Edit at the bottom of the screen. Go into the Joints and Reinforcements page. We can then view the joint codes at the bottom and select number 16 as an allowable alternate. For this example, let's change the default code over on the last 4 lines to carry that 16. The 16 code will now be the default for any size larger than 97 or 85 inches in width. To save the changes, simply go to Menu, Exit, go to the main menu in the top, Job File, and then edit your zone again. Select a new joint of duct, go to the joint connector, and you'll now see the galvanized test connector is an allowable alternate. I'll select it. You can see that the galvanized test connector at 24 by 12 is not the default, therefore it's highlighted yellow. However, it's checked as an alternate. If I change the dimensions to a larger size, we will now see that the galvanized test connector is still on, but is white. Therefore, it is the default. Now we need to look at how moving codes in the data file can affect the pressure files. We just talked about setting up the galvanized test connector and applying it as a default. Let's go back to the data file and look at changing the locations of those joint connectors and what that will do to the pressure files. So to return to the data file, we go to the Job File button in the upper left, go to the Main Menu tab in the upper left, click the Setup Menu button, and then click the Data File button on the left-hand side of the screen. We'll return to the Rectangular Joints and Sealants page where we were just working. Listed on the left-hand side, you'll see all of the different joint connectors that are available, the joint components. Number 16 is the galvanized test connector that we just set up. If for some reason we decided we didn't want our joints in this order, we could easily move locations of these different products. As an example, we'll switch the location of the galvanized test connector and the duct board shiplap. In order to do that, you can simply highlight the line and the description that you want to change, copy and paste it in location of the ductboard shiplap, and then move the ductboard shiplap down to line 16. In order to do this, we would have to do this for each individual column. As you can see, when I click and drag from the beginning of galvanized test connector, going to the right, it never highlights the horizontal cost or description column. For moving the locations of joint connectors, we've added in shortcuts. Simply by clicking on the code number on the left-hand side of the screen, you can tell it to move an entire line of component information from one location to another. As an example, we'll switch the locations of 16 and 15. By clicking on the number 16, you'll see that a button comes up with a dialog box asking you for an operation: copy, clear, or swap. I'm going to swap the location of 16 and 15. By clicking the swap button, I can then type in the number 15 and click OK, and you'll see that the two have been switched. After doing this, we need to be aware of the changes that'll make for the pressure files. So let's leave the data file, Menu, and Exit, and then go all the way back into our takeoff screen, Main Menu, Job File, and then Edit the Zone. It'll reload the pressure file and the data file as those were edited. You can see the last item that we accepted was 90 by 12, and it was using galvanized test connector as the default joint. When I select a new piece of duct, it'll come up with the 90 by 12, as that was the last size entered, but you can see the new joint for it is ductboard shiplap. So the first question is usually, why is that coming up? The simple answer is that we changed the locations of those joint connectors in the data file, therefore the pressure file needs to be changed as well. To do that, we would go back to the job file, the main menu, setup menu, and then we would need to edit the 2-inch pressure file. Visit the Joints and Reinforcements page, and you can see the default code is still the number 16, which is ductboard shiplap. So in order to make this change complete, we would then have to change these codes to a 15. Keeping in mind that the pressure file is only using the code placement of the joint connectors is the easiest way for you to go through and set up the system. So the important lesson to learn here is that if you change the location of your joint connectors, or any of the components including seams and hangers, within the data file you will have to visit all of your pressure files and modify the joint codes that are set up as the defaults, as well as the checked allowable alternates.